Welcome everybody in AP Chemistry series. Today we complete section 8.3 part 2, which is all about weak acid and base equilibria. The second part of our lesson is talking about something called percent ionization. In the previous video, we covered how to deal with weak acids and bases. For example, if we have HF that dissociates in water, produces hydronium ion in addition to the conjugate base of the acid. On the other hand, we covered a weak base like ammonia. It dissociates in water, and then it produces OH negative in addition to the conjugate acid of ammonia. The percent ionization for acid represents the concentration of hydronium ion to the concentration of HF. I mean, like the original molarity of HF multiplied by 100. And the same thing here for the base. It's the concentration of the hydroxide ion with respect to the original molarity of the weak base multiplied by 100. So it's going to be like OH negative divided by the original molarity of NH3 multiplied by 100. So how can I get use of the percent ionization, for example, to calculate the value of acid dissociation constant or the base dissociation constant Kb, or how to determine the pH if we were given the concentration of hydronium ion. We are given a purified weak acid, which is acetic acid or vinegar that dissociates in water, and we can see it produces hydronium ion or hydrogen ion in addition to the conjugate base. On the basis of the information above, what is the approximate percent ionization of this acid and this molarity? So just keep in mind, this represents the original molarity of the acid, which is in here, it's 1 molar. All right. The question is asking me to calculate the percent ionization. Okay, the percent ionization is equal to the concentration of hydronium ion divided by the original molarity of acetic acid or the vinegar, okay, multiply by 100. Okay, so this is my target. I have the concentration of the original acid, but I don't have the concentration of hydronium ion. But we're given the value of Ka, so I can say the Ka expression represents the concentration of H3O plus, as we mentioned before in videos. H3O plus is the same as H positive. It's multiplied by the conjugate base, okay, divided by the original molarity of CH3COOH. Okay. So I just want to use a beautiful rice table right here. This is CH3COOH. It dissociates in water to give you H3O plus CH3COO negative. So at initial time, we have 1 molar, and these are zeros. We just take the change of negative x here, plus x. We neglect the part like 1 minus x. It's neglected in here. We put this plus x. If we write the value of Ka right here, we can say it's the concentration of the hydronium ion and the conjugate base, and they're equal to x's, as we can see. Here we have x and x, so the value is going to be x squared over, we neglect this part because we don't have quadratic equations and AP exams, so I just put 1 right here, and the value of Ka is given to us, which is 1.8 times 10 to the power negative 5. So the value of x is equal to the square root, and the value of x is equal to 0.00424. All right. So we have the value of x, and just keep in mind the value of x is the same as the value of hydronium ion, like it's the same as H3O plus. Since my target is to calculate the expression of ionization percentage, I have to say, okay, I want to erase the stuff. Okay, the concentration of H3O plus is equal to 0.00424, and it's divided by 1, and it's multiplied by 100. So if you just apply this in your calculator, you will end up with a value of 0.42%. And this is the same as the answer in B. And now let's do this question. You can pause the video and read the question carefully. Try it on your own if you can do it. The question says, a solution of cyanide has ionization percentage of, and a pH of 8.2. So first of all, you have to make a common sense that the pH here is greater than 7. And you just think about like it is basic, which means I'm going to deal with Kb, I'm going to deal with OHs, etc. Okay. The first part of the question says calculate the hydroxide ion concentration. Okay. The target is to calculate the OH negative. We're going to calculate the concentration of hydroxide. The only thing that was given to us is the pH. But how can I calculate the pOH? Suppose since the temperature is not mentioned, we can consider it to be 25 degrees Celsius. And that's why we can say that the pOH plus the pH is equal to 14. And since the pH is equal to 8.271 and the pOH is unknown to me and it's equal to 14, if you apply some math, you will end up with a pOH which is equal to 5.729. But the question is asking you to calculate the concentration of hydroxide, not the pOH. So in order to change the pOH into hydroxide ion, you have to take the antilog, which is 10 to the power negative pOH. And that's why it's equal to 10 negative 5.729. And the answer is 1.87 times 10 to the power negative 6 molar. The concentration of H is equal to 1.87 times 10 to the power negative 6 molar. Okay. B says, calculate the original molarity of CN in the solution. Okay. The original molarity of CN is determined by a given information, which is the percentage of ionization. So we can say that the percentage of ionization is equal to the concentration of OH over the original concentration of CN multiplied by 100. Just keep in mind your solution is basic and your base is CN. If it reacts with water or dissociates in water, it will produce the conjugate acid in addition to hydroxide. The percent of ionization tells me that you should divide the concentration of hydroxide over the original molarity of your base multiplied by 100. So all of these guys are here. From my previous example, I have the concentration of OH, which is 1.87 multiplied by 10 to the power negative 6 over the original molarity of CN, which is unknown to me, but the percent of ionization is given to me. Thankfully, I can say like the value is equal to 8.12 multiplied by 10 to the power negative 4. And don't forget the 100. I'll help you out how to do that in terms of math. If you make cross multiplying in here, you will end up with 8.12 times 10 to the power negative 4 multiplied by the CN equals to 100 multiplied by 1.87 multiplied by 10 to the power negative 6. And if you divide this over 8.12 times 10 to the power negative 4, and the same thing here, 8.12 times 10 to the power negative 4, you will end up with a concentration of cyanide to be 2.30 times 10 to the power negative 1 molar. So this is the original molarity of CN. And now let's jump to C. The question is asking me to calculate the value of Kb. If we want to write the Kb expression for this one here, we can say the Kb is equal to the concentration of the conjugate acid multiplied by OH negative over the original molarity of the base. Since the concentration of OH is the same as the concentration of HCN, we can say it's 1.87 multiplied by 10 to the power negative 6 to the power 2 over the original molarity, which is 2.3 times 10 to the power negative 1. And the Kb is equal to 1.52 times 10 to the power negative 11.